forklift with a maximum load of 2000 kg, that is lift plus passenger, is moving up with a constant speed of 1.5 meter per second. The frictional force opposing the motion is 3000 Newton. The minimum power delivered by the motor to the lift in watts is how much? So we know only the total force required to move with constant speed. Total force required force is equal to weight plus friction, which is equal to 20,000 plus 3,000, which is equal to 23,000. F is equal to 23,000 Newton. Power is equal to F into V, which is equal to 23,000 into 1.5 is equal to 34500 watt. P is equal to, power is equal to 34500 watt. Option 1. Our two statements. Biot-Savart's law gives us the expression for the magnetic field strength of an infinitesimal current element of a current carrying conductor only. And the second statement is Biot-Savart's law is analogous to Coulomb's inverse square law of charge q, with the former being related to the field produced by a scalar source, while the latter being produced by a vector source q. So we have to choose the most appropriate answer. Whether statement 1 and 2 is right or both are wrong, or either one of them is right or either one of them is false. So Biot-Savart's law gives magnetic field. It gives Biot-Savart's law gives opinion regarding magnetic field due to current element. Which is a vector source. So the correct statement here is, and this is an incorrect statement, option 1. Resistors of resistance 100 and 200 ohms are connected in parallel in an electrical circuit. The ratio of thermal energy developed in 100 ohm to that in 200 ohm in a given time is how much? So we know that the thermal energy developed across the resistors is H is equal to V square by R into T. Since the resistors are connected in parallel, for some time V and T are constant. Therefore, H is indirectly proportional to R. H1 by H2 is equal to R2 by R1, which is equal to 200 by 100. H1 by H2 is equal to 2 by 1, which is equal to 2:1. Option 4. So the ratio of thermal energy developed in 100 ohm to that of 200 ohm in a given time is 2:1.
The energy that will be
ideally radiated by 100 kilowatt transmitter in 1 hour is how much? We know that energy is equal to power into time. So E is equal to 100 into 10 power 3, because it is in kilowatt, into 60 into 60, it's in hour, so converting into seconds, joules, which is equal to 36 into 10 power 7 joules. E is equal to 36 into 10 power 7 joules. This is of option 3. Solenoid radius of 1 mm has 100 turns per millimeter. If 1 ampere current flows in the solenoid, the magnetic field strength at the center of the solenoid. What is the magnetic field strength at the center of the solenoid? So given R is equal to 10 power minus 3 meter, and N is equal to capital N by, which is equal to current, which is equal to 100 by 10 power minus 3. So the magnetic field strength at the center of the solenoid, is B is equal to mu naught N I, which is equal to 4 pi into 10 power minus 7 into 100 by 10 power minus 3 into 1, which is equal to 12.56 into 10 power minus 2 T. The magnetic field. This is of option 4. Angle have no units and no dimensions, both units and dimensions, units but no dimension, dimensions but units. This is the formula of pay angle, and this is the formula of solid angle. Hence both has no dimensional formula. These both have no dimensional formula. No dimensional formula. They have units but have no dimensional formula. Option 3. Rectification. If the input frequency is 60 Hz, frequency is equal to 60 Hz, then the output frequency will be, so in case of half wave rectifier output frequency, it will always be output frequency is always equal to the input frequency. So in case of half wave rectifier, option 1. Of the AC source is equal to root 2 times of the RMS value of the AC source, 1 by root 2 of the times the RMS value of the AC source, the value of voltage supplied to the circuit, and the RMS value of the AC source. So we know that the VRMS, voltage RMS, is equal to V naught by root 2. So peak voltage is equal to root 2 into VRMS. So option 1, root 2 times of the RMS value of the AC source. Tension of a stretched string is doubled, then the ratio of the initial and the final speeds of the transverse wave along the string is what? So velocity of a transverse wave on a string is equal to root of T by mu, where T is equal to tension of the string and mu is equal to mass per unit length. So V1 is equal to root of T11 by mu1. As per the question, T2 is equal to doubled. Initial tension is equal to a stretch string is doubled is equal to 2 times T. So V2 is equal to root of T2 by mu. V1 by V2 is equal to root of 1 by 2, which is equal to 1 by root 2. Option 1. Length of 121 cm and 100 cm start vibrating in phase. At some instant, the two are at their mean position in the same phase. The minimum number of vibrations of the shorter pendulum after which the two are again in phase at the mean position is what is the minimum number of vibrations. So the time period of a simple pendulum is equal to T is equal to 2 pi root of L by G. So T1 by T2 is equal to root of L1 by L2, which is equal to root of 1.21 by 1.00. Since it is in centimeter, we have converted into meter, which is equal to root of 121 by 100 is equal to 11 by 10. So 10 T1 is equal to 11 T2. Option 3. Occupied by molecules containing 4.5 kg of water at STP if the intermolecular forces vanish away is in the absence of intermolecular forces, water will exist in vapor phase. Water will exist in vapor. So PV is equal to N of RT. PV is equal to M by M RT, which is equal to 1.01 into 10 power 5 into V, which is equal to 4.5 into 10 power 3 by 18 into 8.3 into 273. Thereby V is equal to 5.6 meter cube. Option 2. Projected with a velocity of 10 meter per second at an angle of 60 degree with a vertical direction, its speed at the highest point of its trajectory. What is the speed at the highest point of the trajectory will be? So the angle with the horizontal will be 30 degree. Angle at horizontal will be 30 degree. How? Because at vertical direction it is 60 degree. Therefore, at highest point of trajectory, the vertical velocity is 0. The vertical velocity is 0, but horizontal velocity remains non-zero. That is, cos 30 degree is equal to 10 into root 3 by 2, which is equal to 3 meter per second, which is option 4. So the vertical speed at the highest point of the trajectory will be 5 root 3. It is used to determine the value of unknown resistant X by adjusting the variable resistance Y as shown in the figure. For the most precise measurement of X, the resistance of P and Q is what? So for most precise value of X, we have to find out X. The ratio of PQ needs to be equal to 1. Ratio of PQ, it should be equal to 1. Also, PQ needs to be small. P comma Q, it should be small. Resistance should be present. As a student use the large value of P and Q. The current through the arms will be feeble. So this will make the accurate determination of null point to be difficult. So the option is 4. Should be approximately equal and or small. Charges minus Q and plus Q are placed at a distance of L. Minus Q and plus Q, as shown in the figure. The magnitude of electric field intensity at a distance R, wherein R is greater than L, varies as. So electric field due to a dipole at a point is there. We are going to represent it like this. At an angle theta R, where they are given as R is greater than L, is equal to Kp by R cube root of 3 cos square theta plus 1. 4. Since EP is indirectly proportional to R cube for short dipole, the option will be 4. 1 by R cube. Statement 1 is labeled as assertion, other one is reason. We have to say whether both the assertion and the reason are right, whether the assertion is right and the reason for the assertion is wrong, or vice versa. And the assertion is the stretch of a string is determined by the shear modulus of the material of the spring, whereas the reason is the stretching of a coiled spring of copper has more tensile strength than a steel spring of same dimensions. So in right of the above statement, we have to choose the most appropriate answer. The assertion is true. How is? As the spring constant is determined by shear modulus of the material of the spring, whereas the reason is false because Steel has more tensile strength, not copper, steel. Steel has more tensile strength than the copper. So it will be option 1. Assertion is true, whereas reason is false. Mass number 189 splits into two nuclei having mass number 125 and 64. The ratio of radius of two daughter nuclei respectively. What is the ratio of radius of two nuclei? So R is equal to R naught A to the power 1 by 3. So R 125 by R 64 is equal to 125 by 64 to the 1 power 3, which is equal to 5 by 4. That is 5 is to 4. Option. So the ratio of radius of two daughter nuclei 5 is to 4. Option 1. To match the given formulas, gravitational constant is m to the power minus 1, L to the power 3, T to the power minus 2. So A2 next is gravitational potential energy, that is m L square T to the minus 2. B4 this is gravitational potential L square T to the minus 2. C1 and D, which is remaining gravitational intensity, L T to the power 1 minus 1. D3, which is option 4. Coil has 1000 turns. An average radius of 10 meter is rotating about its horizontal diameter of 2 radius per second. With the vertical component of the Earth's magnetic field at the place is 2 into 10 power minus 5 and the electrical resistance of the coil is 12.56 ohm. The maximum induced current, what is the maximum induced current in the coil? So, maximum induced current in the coil is equal to NBA watts. This is equal to E max by R, which is equal to NBA watt by R, which is equal to 1000 into 2 into 10 power minus 5 into pi to 10 power 2 into 2. 5, 6, which is equal to 2 into 2 by 12.56, which is equal to 12.56 by 12.1 ampere, which is option 1. Media A and B are separated by a plane boundary. The speed of the light in those media are 1.5 into 10 power 8 meter per second and 2.0 into 10 power 8 meter per second respectively. This is 8 power 8. The critical angle of a ray of light for these two media is what? We have to find the critical angle. Sin I is equal to mu R by mu D, which is equal to C by VR into VD by C, which is equal to VD by VR. 1.58 into 10 power 8 by 2 into 10 power 8, which is equal to 3 by 4, which is equal to 0.75. I is equal to sin inverse 0.75, which is option 0.75, option 4. With induction 10H, inductance 10H and capacitance 10 mu Faraday and microfarad and resistance of 50 ohm is connected to an AC source of voltage. V is equal to 200 sine of 100 t volt. If the so-named frequency of the LCR circuit, if the resonant frequency of the LCR circuit is V naught and the frequency of the AC source is V, then V naught is equal to, whether it is 50 by hertz and V is equal to 50 hertz, V is equal to 100 hertz, V naught is equal to 100 by pi hertz, V naught is equal to V is equal to 50 hertz and V naught is equal to V is equal to 50 by pi hertz. So the resonant frequency 2 pi V naught is equal to 1 by root of LC, which is equal to 1 by root of 10 into 10 power 6 into 10. 100 V naught is equal to 50 by pi hertz. V is equal to 200 sine 100. A capacitor of capacitance C and 900 Farad is charged fully by 100 volt battery B as shown in figure B. Then it is connected from the battery and connected to another uncharged capacitor of capacitor C 900 as shown in figure B. The electrostatic energy stored by the system B is how much? U initial is equal to half CV square, which is equal to half C into 100 square, which is equal to 5000 C. Lost delta U is equal to half C1 C2 by C1 plus C2. V1 minus V2 the whole square, which is equal to half C square by 2C 100 minus 0 square, which is equal to 1 by 4 C 2500 C. U final is equal to U initial my delta U, which is equal to 5000 C minus 2500 C, which is equal to 2500 C. 900 into 10 power minus 12, 225 into 10 power minus 8. U final is equal to 2.25 into 10 power minus 6 joules, which is option number 1. From Ampere's circuitous law, for a long straight wire of circular cross-section carrying a steady current, the variation of magnetic field inside and outside of the region of the wire is a linearly increasing function of distance r up to boundary of the wire and then decreasing 1 with 1 r dependence for the outside region. A linearly decreasing function uniform that remains constant for both the regions, or linearly increasing function of distance up to the boundary of the wire and then linearly decreasing for the outside region. We have to find which of the 4 options is right. For a cylindrical wire of radius r carrying steady current for r less than r, then B, the magnetic field is proportional to r increasing. For r greater than r, then B, magnetic current is inversely proportional to the radius, therefore decreasing. So option 1, that is the variation of magnetic field in the inside and outside region of the wire is linearly increasing function of distance r up to the boundary of the wire and decreasing 1 with 1 by r, actually that is 1 by r dependence of the outside region.
Table for the given logic circuit is, these are the options, option 1, 2, 3 and option 4. First we'll draw the truth table. It's actually drawn here. We'll mark it actually. Here they have given A, B and C. A, B, A bar, Y2 is equal to A bar to B, Y1 is equal to and Y2. So the truth table will be so it will be 1 1, it will be 1 0 0, 1 into 1 1, 0 1 0. That is 0 0 1 0 1 0 1 0 1 1 1 0.